this is an overview of the steps for calculating a stoichiometric calculation. So step 1, we need to balance the equation. Now for steps 2, 3, 4 and 5, I'm actually going to set up a table first to make it easier to follow. So I create a column for each of the species in the reaction, and I also create a column to the far left, and I'm going to label my 4 rows that I'll be using. The first row is the mass, which I will label lowercase m. The next row will be the molar mass, which I label mm. The third row will be the number of moles, which I label lowercase n. And the last row will be the mole ratio, which I just label R. Now I can fill in the information that I've been given from my question. So we have 1.00 times 10 to the 3 grams of lithium hydroxide, and the question asks us to find out the mass of carbon dioxide. I put a question mark here just to remind me what my final answer will be, so it helps me know where I'm going. Now the molar masses, we're able to use the periodic table to find the molar masses of any compound. If the question gives you the molar masses, then you don't have to calculate that. So the molar mass of lithium hydroxide is 23.947 grams per mole. And for carbon dioxide, the molar mass is 44.009 grams per mole. So, for these steps, what we're effectively doing is we will be calculating the number of moles, and we do this with the information we've given. We travel down our column, and then we're able to travel back up and find out our final answer. To find out the number of moles of lithium hydroxide, we simply divide our first 2 terms. In other words, we're using this formula to find out number of moles. And if we divide this term by this term, we get 41.759 moles. Our mole ratio, we simply write down the coefficients in front of our species. For lithium hydroxide, the coefficient is a 2. For carbon dioxide, there's no coefficient, which implies the coefficient is 1. This gives us our mole ratio. It's a 2-to-1 ratio, and we apply this ratio to our mole calculation we worked out for the lithium hydroxide. Using dimensional analysis, we put the term on top that we want to find out. So that's CO2, and this is lithium hydroxide, and that will give us 20.880 moles. And now we're working our way up this column, and we multiply our number of moles by our molar mass. Effectively, we're using n equals m over mm, rearranged, m equals n times mm, and that will then give us our final answer, which is 9.19 times 10 to the power of 2 grams. And this becomes our final answer.